So I've shown you this mythical programming language. You're probably saying something like this can never exist. Let's first talk about what it is. So first, we'll say, why does something like this have to exist? Or why should it exist? And the problem here is that everything I've shown you on the previous slides, all of these things, this peer-to-peer replication, the databases, the code on the client, all of these things I've shown you might seem like so amazing. Maybe they don't. Maybe some of you say, hey, that's commonplace. But the interesting thing here is everything I've shown you exists today. It doesn't exist under a single programming language, but there are systems and algorithms, and there are papers, and there are prototypes, and there are industry applications. All of these things already exist, okay? The problem is that they exist in isolation. And that means as developers, our job is not only converting our business logic into an implementation, but we also have to think about how that implementation maps to existing systems and how we glue those existing systems together. And so as application developers, unfortunately, the reality of it is that we are responsible for gluing services together. I might say my events come in through Kafka, I may store that information in HDFS, and then maybe I do some learning on Spark with it, right? And so Jerry Sussman basically, when MIT moved from Scheme to Python, said, the change is interesting. It makes sense because application developers today don't build things from scratch. They don't build all of the stuff anymore. What they do is they are really connecting together existing libraries. And this kind of rings true. Anybody who builds an application, we think about it as gluing things together. Now, from an academic perspective, we don't like this at all. What it means when you glue things together and you have APIs as the boundaries for gluing things together, it means that you roughly have an ad hoc programming model. This ad hoc programming model has very weak or unspecified semantics. And largely, these semantics are defined by implementation. So as language designers, we like to make semantics and implement them. And, when we think about service composition through APIs, what we do is we write an API, we reverse engineer the semantics. Can I plug this thing that uses exactly once messaging into this thing that uses at most once messaging? Well, I don't know. Maybe. And so historically, it's very interesting if we look at this because there have been systems that have tried to do the pie in the sky, the greenfield system. Most notably here, I will talk about Argus. Argus is a system by Barbara Liskov that was a genesis, kind of an evolution of Clue. This system is one of the systems that invented modern exception handling. Iterators come from the system. Promises, if you've ever heard of those, come from the system. Argus is a greenfield system for transactional, fault-tolerant RPCs, transactional guarantees across services. Nobody uses it. Nobody knows of it. Right? Nobody knows this. Nobody uses Argus here, I'm sure. Argus, interestingly enough, is the reason for X Windows existing. I can tell you that story if you see me later. And so these systems have no adoption. What does have adoption? Well, Corba has adoption, right, historically. And Corba, as anybody here who's ever used Corba knows that Corba is a nightmare. It is terrible. It is the idea that we can retrofit systems running different languages, running different architectures. Middle endian, big endian, little endian, it doesn't matter. We'll convert the formats. Relative pointers in memory, who cares? When I send you my data, you can just store it in memory the same way, so the pointers match up. I mean, this stuff is insane. We would never think about building a system this way. But Corba historically, high adoption.